Okay, so I have not, the units, I'm not being careful here. Let's see. This, I can see that I have only partial units. I have newtons per meter when in fact we've got newtons per meter squared. I get rid of one of the meters. So we have newtons per meter second squared. Newtons per meter second squared. That is a crazy unit. Newton per meter second squared. No, it's because it's newtons second squared per meter. Thank you, whoever you are. Okay, so man, it's getting late, so my brain isn't working very well. Newton per meter times second squared. We know that a newton is a kilogram meter per second squared. So multiplying it by second squared gives me essentially, I lose this, the seconds, and the newtons, the meters, I lose that. So I end up with kilograms. Is that right? Kilograms on this side? No, that's totally, something is wrong with that. I need to fix that. Okay, let me go back up to my equation here. Pressure difference, expecting to have force per area, newtons per meter squared. That looks right. That goes into this part of the equation. Let me turn the page. Oh, the density, I left that out. Ooh, horrors. Okay, no, I didn't leave it out. Meters per second squared. Density down here. Pressure here. Velocity here. Units should work out. This should be, it should have meters squared per second squared. What do I have here? Pressure, newtons per meter squared, divided by kilogram per, kilograms per meter cubed. What? Oh, haha. Density, mass per volume. This is what I did wrong. If I go here, I put density as meters per second squared, 9.8 meters per second squared. I use gravity instead of density. I don't know what is going on with my brain, except that I had far too many brownies today. So I apologize here. So let me erase this. This is actually, should be density. Let's get this in here. And this should be density, which is what? Density of what? Water? Water. Yes, water. Kilograms per meter cubed. That will give me the units of, let me erase some of this stuff here. Kilograms per meter cubed gives me newtons. I know this is kilograms meters per second squared. If I divide it by kilograms per meter cubed, I end up getting what I wanted was meters squared per second squared. Okay, I just wanted to check that. So let's get, this value is wrong because I plugged that in wrong. So let's come down here. Let's just erase most of this. Except that I do want to keep this guy here. I know this is area 2 over area 1 is 1/3. So when I square that, to put that into this value, I get 1/9. So I get on this side V2 squared times 1 minus 1/9 equals, let me just see, 1, 2, 3. So about 220 meters squared per second squared. I'll turn to the next page. 220 meters squared per second squared equals V2 squared times 8/9. 1 minus 1/9. So we've got over here 9/8 of 220 meters squared per second squared equals V2 squared. Okay, so V is about equal to the square root of 9 times 220 divided by 8. Let me see if I can simplify that. 220 divided by 8, what is that? Whew. Now the square root of 9 is 3. I'll pull that out. 220 divided by 8 is about 30, less than 30. So that the square root of that is going to be, I know it's meters per second. So we've got meters per second, sort of 5. I'm going to say this is going to be somewhere between 5 and 6, so 5.5. I don't know, 5.5 times 3. So I'm going to say the square root of the 30. I'm going to say that's about 5.5 times 3 is 15, 16, 17 meters per second is approximately equal to the velocity. What the heck were we looking to get in this problem? Velocity. If I go back to the problem, this is kind of a long problem. It's very long when it's way past my bedtime, so my brain is not working. What is the volumetric flow rate? Okay, we're getting there. So this is the velocity 2. Velocity 2. So this is the constricted area. So the volumetric flow rate, Q, is equal to the area times the velocity, 2, will equal to pi over 4 times the diameter squared, which is 0.15 meters squared times 17 meters per second. Q, 0.15, what is 0.15 squared? 0.15 squared is a small number. Put 5, 10, 15, 20, is it like 200.02, something like that? This is like 3/4, 0.75 times 17. Wow, it's hard to do math when you're tired. This is what I notice. This is about, I'm going to call this 0.2 meters cubed per second. That's what the Q is equal to. I'm guessing. Now I'm going to use a calculator. I think I have one. I'm just going to plug that in just to get a closer value for you. And I am not very awake. Enter 0.15 squared times 17 times. Oh, check it out. 0.29. Okay, so Q is about equal to 0.29 meters cubed per second. Well, that was a good guess for being tired. Okay, I hope that helps.